Assalamualaikum warahmatullahi wabarakatuh. We are from Group 8. We'd like to present our group project, and the members of our group is Muhammad Shahid bin Fitri, Muhammad Zuhelmi bin Rosli, and myself Sitima binti Khairuddin, Nurhazika Izzati binti Hassan Hadi, and Nurhazwani Izzan binti Suhami. Me is Sitima binti Khairuddin, and I would like to present about the introduction. On this project, we have developed the design of basketball stadium with the standard size pitches with 28 times 50 meter, which would be made of steel plate and aluminium plate construction. Design concept of our basketball stadium uses a type of truss that will be used is planar truss, and because of its stretchability and workability, it has all its members arranged on a two-dimensional plane. Only axial force are caused in the structure since the members are bound with a joint that is either bolted or welded. External loads are applied in such a way that their effects are in the form of forces that only occur to joints, which is why axial force exists. A stadium design must please three major groups of people regardless of intended use, which is spectator, athletes, and stakeholder. Every stage of the long-span steel truss erection from design to implementation must be completed effectively in order to reduce or limit risk to the greatest extent possible. And lastly, for the engineering judgment, trusses are quick and easy to install, can create load distribution, and can cause an increased distance. And next, I would like to present the design plan of our basketball stadium. And this is the roof plan, which is fully covered, and the basketball stadium plan view, which is fully equipped with row of seaters surrounding the basketball court. And this is the arrangement of truss by using Howe truss. This is the front elevation, and the bottom is the side elevation. And lastly is the plan view basketball stadium of the foundation, drawing, and the fully designed truss. That's all. Thank you.
Assalamualaikum. My name is Nurhazwani Izzan binti Suhami. Metric number CF190014. For load computation, we use rectangle 0.05 kN per meter square, service 0.2 kN per meter square, weight of roof sheet insulation and purlin 0.5 kN per meter square, permanent action GK 0.75 kN per meter square, and variable action QK 0.75 kN per meter square. Permanent load is 0.50 kN per meter square. Variable load is 0.75 kN per meter square on slope. Distance of purlin is 3.75 meter. The WP is 47 kN and the angle used for purlin is 261. The D value is 222.22 mm. Assume set row are assigned on the middle of purlin between two trusses. Thus, the B value is 83.33 mm. Therefore, single angle used is 200 times 200 times 24. For load transfer to the truss on slope, permanent load 0.65, total permanent load 24.44 kN, variable load 0.75, total variable load 28.2 kN. So the design load is 75.29 kN.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shahid bin Fitri, and I will continue to the chapter 3, which is determination of internal force. From the instruction, we need to find the internal force using a software. Our group choose a LimPro software to find the internal force of the truss. As we can see from the slide, we need to insert the reaction of A, reaction of B, and the design load from each member from top chord. From the software LimPro, we can get the axial force or axial load or internal forces from the truss. we can get it for top chord, bottom chord, diagonal brace, vertical brace, and we can comparison it with manual calculation. As we can see from the slide, this is a Azure load from the software of Limpro. As we can see from this slide, we compare it with the software and manual calculation for bottom chord, top chord, vertical brace, and diagonal brace. So far, there's a difference between Limpro and manual, which is the big gap, and also there's a no big gap from the both of way. After that, from the Limpro software, we get the critical and tension member, and we need to calculate it for every member of our group. We need to find the critical and tension member from the trusses, and we need to summarize the tension and compression member.
Assalamualaikum. My name is Muhammad Zulhami bin Rosli, CFR Management 1. So I'll be continue presenting on chapter 4, critical compression members and critical tension members. So from the chapter 3 that we got all the internal members false. So this is we choose 5 for critical compressions and 5 for critical tensions. This is members and the Azure loads. Next, so we choose top chord 12 for example on calculation of critical compression member. So specifications, we have the load which is 422.58 Newton. We provide the size RHS, so 100 times 60 times 6.3. We got the informations, all informations from these tables. The secret is S275. So first we have to find sections classifications. So for epsilons, the formula is square root 255 over Fy, which is 275. We got 0.192. So we have to find for web and for flange. We assume it is class 1. So for web, the COT is 6.52, must be less than 33 epsilon, which is 3.6. So it is class 1. For flange, it must be less than 9 epsilon, which is 8.8. So we also got it class 1. So the other sections is class 1. So NCRD is equals to AFY divided by gamma M naught, and we got 197.75 kilo. NED must be less than NCRD. So NED divided by NCRD, we got 0.85, which is less than 1. So we have to find the bucking resistance of sections. We got critical length LCR, which is 3.819 meters. We have to find NCR, which is equals to pi squared EI divided by LCR squared, which is 4,590 per meter. Find the lambda, we got 0.23, the alpha is 0.1, so the phi is 0.62. We have to find NVRD, XAFI divided by gamma M1, which is 433 newtons. NED divided by NVRD, we got 0.98, which is less than 1.0. So the cross sections that we provided are HS 100 times 60 times 6.3 with S 275 acceptable and can be used in truss systems. So this is summary for critical compression member and critical tension members calculated. So all the size provided have a pass status. Thank you.
Hi, Assalamualaikum. My name is Nurhadi Izzati Binti Nurhadi. My matric number is F90056, and today I would like to present the chapter 5 of our project, which is a connection. Now let's move to the connection type. For all the type of member section, it is possible to design either bolted or welded connection. Analyze of trusses assume pin joint connection regardless of the actual type of connector used. The loads are applied exclusively through the panel points even though in reality, this will not normally be the case. The system line of truss members should precisely meet at the panel points. In practice, this can hardly be achieved. Trusses almost invariably have eccentric connection, which exert additional stresses on members and connectors. Adequate margin to stress limits needs to be allowed for. Here is the example of photo for the connection type. Now, I will gladly explain about the connection design of our project. As we use a bolt connection in our project, we use a double shear and splice connection, the M20 grade 4.6 bolt in 24mm. The splice plate is grade S275 and the membrane beam of 1. The first one is we check the detailing requirement for E1, E2, P1 and P2. And next, the actual distance fulfilled in minimum distance. The maximum requirement, this is the formula for the maximum requirement. And the smaller of actual P1s we get is 52.8mm. And this is okay because it's less than 200mm. And now we move to the check shear resistance per bolt for 2 shear plate. This one we calculate the FBRD and we get the answer is 1128.96 kilonewton. Move to the next step is check bearing resistance per bolt. This one we get the AB used as 0.4 and the K1 is used 1.38. Now let's move to the bearing resistance of one shear plane per bolt. I'll take the smallest and corresponding strength. This one we calculate the FBRD using this formula and we get 29 kilonewton. But we must multiply with 12 bolt, which is the number of bolt we use in this project, and get the 348 kilonewton. The next step is check tension resistance. This one for calculate FTRD using this formula also, where K2 is 0.63 and we get the answer is 50.6 kilonewton, but as always, we need to multiply for the number of bolt and get the 607.2 kilonewton. So the answer is shear resistor FBRD, bearing resistor FBRD, tension resistor FTRD for the calculation. And the strength of this splice connection is covered by shear force resistor. FBRD is 1128.96 kilonewton. That's all from me. Thank you.
For conclusion, the steel column is designed to support the steel truss with the base below the steel column. The steel truss and purlin will support the roof and load above roof. Prior to proceed the design of steel element, it is important to evaluate the load combination based on load identification. The main focus on creating load combination is for design and analysis. This steel truss design of a stadium has run the LIMPRO software for design and analysis. Thus, the LIMPRO software will be verified the design they are stable and no failure. For the safety purpose, the size of steel design must be large for resist the load. While for economic purpose, the size of steel must not too large and just suitable to resist the load.